For most of human history, finding new materials was all about happy accidents and a ton of slow, painful trial and error. But what if we could just stop searching? What if we can start inventing, actually designing the exact materials we need atom by atom? Well, this isn't science fiction anymore. Today, we are diving into a system that's trying to do exactly that.
I mean, just look at this difference. On one side, you have the old way, relying on pure luck where a single breakthrough could take decades. And on the other, a totally new way of thinking. Intentional design. It's driven by the fundamental language of matter itself, something called resonance. This isn't just a small step up, it's a massive leap. It's about going from finding what's already out there to creating what we actually need. We're talking about potentially turning 20 years of research into 20 days of computation.
So, to really get our heads around how this is even possible, we're going to take a journey through 5 key areas. First, we'll look at the big, audacious vision. Then, we'll learn the language it uses to literally talk to atoms. After that, we'll meet the digital specialists inside its engine, see it in action with a real-world example, and finally, and this is super important, we'll explore the critical rules that govern its incredible power. All right, so let's jump right into the core concept. At its heart, NeutronAlchemist is a tool with a wildly ambitious goal: to be a kind of digital alchemist for our time, one that can design totally new forms of matter. Okay, let's pull apart this official mission statement, because there are some key phrases in here. The big ones are resonance first and spectral resonance objects. See, instead of seeing atoms as these tiny little billiard balls, this system sees them as unique vibrations, like musical notes. It builds materials like a composer writes a symphony. And it does all of this while being locked down by built-in safety rules that it absolutely cannot break.
So that brings us to the really fundamental principle here. To design matter, you have to speak its language. And for neutron alchemists, that language is resonance. It's the collection of frequencies and vibrations that defines every single thing in our universe.
Think of these as the absolute ground rules of that language. First up, resonance first. That's the grammar. Everything is defined by its vibration. Next, duality makes sure that the digital model is a perfect mirror of physical reality. Then there's lawfulness, and this is so crucial. This isn't magic. The system has to obey the fundamental laws of physics, like conservation of energy. Those are hard constraints. And finally, the hyperspectral memory is its massive library, its brain, storing every recipe and fingerprint it ever learns.
So, how does it keep track of all this information? Well, it uses something called an atomic spectral tensor, or AST for short. The easiest way to think about this is like the ultimate high-definition barcode for matter. It's this incredibly rich mathematical signature that describes everything about an atom: its energy, its shape, its spin, all translated into the language of spectra.
Now let's meet the team that actually makes all of this happen. Inside this digital alchemist, there's a set of core systems, and each one has a very specific job. They work together just like a super specialized research group.
First up is Atom LLM. This is the creative dreamer of the group. It's a generative AI, a lot like the ones you've seen that create text or images. But this one has been fed a massive diet of scientific papers and databases. Its job is to dream up new possibilities, new ways to arrange atoms, new types of bonds, new materials that have literally never existed before. Of course, a dream is just a dream until you test it against reality. And that's the job of the RPU fabric, the reality simulator. This is a piece of specialized hardware, a custom chip, designed to do one thing incredibly fast: simulate the physics of the materials that Atom LM dreams up. By calculating how all the waves would interfere, it can figure out almost instantly if a new material would be stable or if it would just poof, fall apart. And finally, we have PhenoMap, the property analyst. So once the RPU fabric confirms a material can actually exist, PhenoMap steps in. It takes that unique spectral fingerprint, that barcode we talked about, and tells us what the material can actually do. Is it a good conductor? Is it super strong? Is it transparent? This is what tells us if our new creation is actually useful for anything. Okay, so theory is great, but we've met the team. Now let's actually see them in action. To make all this feel a bit more real, let's walk through a tangible example, designing a brand new superconductor.
So it all starts with a clear goal. We want a superconductor that works at a reasonably high temperature. Atom LM gets right to work spitting out ideas for layered materials that it thinks might have the right vibe. Then, the RPU fabric just hammers away, stress testing thousands of these ideas for stability. After that, another specialist called Atom Mutant steps in to intelligently tweak the best ones, swapping out an atom here, changing the structure there to fine-tune them. Finally, the system picks the absolute best candidates and flags them for human scientists to come in, review, and verify.
This brings us to what is, without a doubt, the most important part of this entire explainer. A tool that can literally invent new forms of matter is, well, it's unbelievably powerful. And with that kind of power comes an immense responsibility to make sure it's used safely and for good.
This quote gets right to the heart of the safety philosophy. And let's be clear, this isn't a suggestion, it's a hard-coded, non-negotiable rule. By default, this whole system operates in a purely digital sandbox, especially when it comes to anything that could even hint at a dangerous use.
And the safety measures are deep, they're layered. Any potentially high-risk discovery gets automatically quarantined and requires a human to review it. The system will flat-out refuse to give you a step-by-step recipe for how to physically make something. Every single action is tracked on a secure ledger, and to even think about moving from a simulation to a real-world lab requires approval from multiple different people. Safety isn't an add-on here, it is baked right into the core architecture.
And these guardrails are absolutely essential, because the stakes, well, they couldn't be higher. On one hand, you have world-changing benefits, new materials for clean energy, advanced medicines, incredible catalysts. But on the other hand, the risks are just as huge. Dual-use materials that could be weaponized, or just consequences we can't even predict. This whole system is designed to walk that razor's edge with extreme caution.
So, when we boil it all down, what we're really looking at is a fundamental paradigm shift. We're moving from a world where we were limited to the materials we could stumble upon to a world where we are limited only by our own imagination, and, of course, our understanding of the laws of physics. It's a true move from discovery to design.
And that leaves us with a pretty profound question, doesn't it? This technology provides the how, but it's up to us, all of us, to answer the what and the why. If we really gain the power to invent any material we can dream up, the most important question won't be a scientific one, it'll be a human one. What should we create?